question from the November 2018 grade 12. In the diagram below, the equation of the circle with center F is given by that S is a point on the circle with center F. Another circle with center G has those coordinates in the fourth quadrant, touches the circle with center F at H, such that FH is to HG is equals to 1 over 2. The point J lies in the first quadrant, such that HJ is a common tangent to both these circles. JK is a tangent to the larger circle at K. We know that this should be equals to 90 degrees because of the radius perpendicular to the tangent. And the coordinates of F should be 3 is to 1. When you say x minus 3 is equals to 0, the x becomes a 3. And it's the same is true for the y. So this is 3 is to 1. .1. Write down the coordinates of F. F is 3 is to 1. 4.2. Calculate the length of FS. Fs is the radius. So Fs is equals to x of s minus x of f plus y of s minus y of f squared. X of s, that is a 6, x of f, it's a 3 squared, plus y of s, 5 minus 1 squared. 6 minus 3 squared plus 5 minus 1 squared. Six minus 3 squared plus 5 minus 1 squared. I am getting 5 units. 4.3. Write down the length of HG. We are told that FH is to HG, which is 1 is to 2. FH is equals to Fs, because Fs is the radius and so is FH. This is Fs. So it means that the length of HG is equals to 10 units, because it must be 2 times Fs. 4.4. Give a reason why JH is equals to JK. This is because there are tangents that are drawn from a common point to the circle. 4.5. They want the distance FJ with reasons if it is given that JK is equals to 20. This is equals to 20. It means that JH is equals to 20 as well. I know that that must be a 90 degrees, and I am searching for FJ. FHJ is equals to 90 degrees. The radius is perpendicular to a tangent. FH squared plus HJ squared should be equals to FJ squared, and this is because of the Pythagorean theorem. FH, that's a 5 squared, and then HJ, that's a 20 squared, is equals to fj squared. This means that fj is equals to square root of 5 squared plus 20 squared. This is 5 root 17 units. 4.5.2. The equation of the circle with center G in terms of m and n in the form. The coordinates, the x coordinates there of G is m and the y coordinate is n squared. The radius there is a 10. This is a 10 squared. 4.5.3. The coordinate of G, if it is further given that the equation of the tangent JK is x is equals to 22. So JK lines on the line x is equals to 22. We have this radius being 10. And of course, GK is a radius as well. This is 10. And then that's a 90 degrees. So the line of y here, it is y is equals to n. Okay. GK. So at G, this is GK. Let's think of this as a number line. Here I have the value x is equals to 22. And then from G to K, that length is equals to 10. So if I want the length here, I must say 22 minus 10 to get the length, the x value there. It means that m is equals to, because this is a 90 degrees, so it would definitely be like this line will be parallel to the x-axis. So m should be equals to 22 minus 10, which is equals to 12. That's a 10. So this is 12 is to n. I have this whole length because I know that FH is 5 and then HG is a 10, and I have only one unknown value. So I will use the distance formula. FG is equals to x of G minus x of F squared and then plus y of G minus y of F squared. F of G, that's 15 because of the 10 plus 5 squared is equals to x of G, that's a 12, minus a 3. The coordinates there were 3 is to 1 squared plus y of G n minus a 1. So this is 2, 2, 5. Just going to say 15 squared minus 12 minus 3 squared. That's a 144. N minus 1 squared. So n minus 1 is equals to plus minus 12. I just took the square root of both sides. N minus 1 is equals to 12, or n minus 1 is equals to negative 12. N is equals to 13, or n is equals to negative 11. the value of y in the fourth quadrant cannot be positive, so n must be equals to negative 11. The coordinates of G is 12 is to negative 11.